Welcome back, my algebra friends. I hope this finds you well today. I apologize for my absence. I will be at a math conference most of the day. I will be after school tomorrow if you have any questions. The main thing that you need to know is that next Thursday, we're going to take our quiz for Unit 4. I will see you next Tuesday. I'll tell you, exactly what we have there, and also you're going to get a midterm review packet. And that is going to be due next Thursday as well. Okay, so you have 2 classes to get that done. Again, I'm after school on Friday. I'll be after school next week, Tuesday and Wednesday. So you should have shown the substitute your homework from graphing. Okay, I'd like you to take a second to read this, solve it. You should be pausing the video to read and solve it. So it wants to know when will they be the same. The point was 3/8, and this has to do with minutes, and this has to do with the price. One thing that we should look at is at the end of this graph, all right, they're not using arrows because we're not going to have negative miles. So if you were building this graph and you put arrows on it, that would be a problem. Okay, second question is a review question from statistics. I'd like you to read it and answer it. So please pause the video, read it and answer it. That means pause it, read it, answer it. All right, so if they have the same mean, that means if you add them up and divide by 10, they have the same score there. And then this is, asking you, do you know what standard deviation is? So we don't know anything about the median. The scores aren't on average 12.5% or 12.5 points higher. But Nick's scores are more spread out because standard deviation measures how spread out the data is. Okay, so I'd like you to check your homework. Make sure that you labeled at least one of the lines, all right? And then my answer was -2.6. I'd like to show you in the calculator how you could check this. So if you could please get out your calculator. And you're going to go into y equals, and you're going to put one equation in y1, one equation in y2. Throughout this whole video, just pause or rewind if I've gone too fast. There are 2 places I could check my answer. I could go second graph, and then I can see right here at -2, both y values are 6. Okay, but we could get answers that aren't whole numbers, so those wouldn't show up in our table. So if we actually go to the graph, there's a series of commands that you can do. So watch my key history and listen to my voice, I guess. So you hit second trace, which is for calculate. We want this one right here, number 5, for intersect. So I will push number 5. And then it asks you 3 commands at the bottom of the screen right here, first curve, second curve. If you only have 2 equations in there, you can just hit enter 3 times. 1, 2, 3, and then it tells me at the bottom -2.6. I would use this a lot for like multiple choice. If I have to show my work, this is just a way to check. All right, so here's the second one on the top right of your page. Again, make sure you've labeled at least one of them, and we got the 0.32. Here's the next one. Make sure you labeled it, and this is the 0.03. Make sure I have a label. All right, so I think this one is a little bit different. Yours says 2.7. Okay, so as long as you drew 2 lines that cross at 2.7, you understand that concept. All right. The next one was have no solution. You should have drawn 2 parallel lines so they have the same slope. And then you have to have it look like mine if you have a vertical and a horizontal at -3.6. I need a vertical at x equals -3 and a horizontal at y equals 6. All right. The last page, they're trying to get you to read off the graph. So the membership was my y-intercept was 50. The two crossed at 5 months for $125. And then if you wanted the monthly charge, they wanted the slope of that. You could have counted it, okay, but you should have gotten 15. This last part is a little bit review. This is called function notation. Whatever number is here goes in for x. So 2 squared plus 3 gives me 7. This is the one that I'm concerned about. If you don't put the negative in parentheses in your calculator, you would have gotten +1, which we don't want. And the last one, you should have gotten 141 when you plug that in. Okay, so you can put your homework aside. We are going to start on page 10. So you're going to take these notes in your note packet, and then you can start the homework, or you can work on the midterm review. So we have a science club. Eventually, we're going to have to take a paragraph and make our own system from this, but we're looking for totals. So science club wants to buy a new telescope. How exciting. Let's see some planets. And they work inside or outside, but they can only have so many people working. So our totals are 240 to buy the telescope, and that uses $16 to work outside and $10 to work inside. And then our other total is we can only have 18 people work, okay? So that's where these numbers came from. Eventually you're gonna build those up. Here they showed you the graph of it, and they wanted you to estimate what you thought right there. Okay, so for B, you're gonna just estimate what point you think that is. Again, X is the number of workers that were outside, and Y was the number of workers inside. So for us, this tells me the number of workers inside, which is my X, and the number of workers outside, which is my Y value. Okay, part D said if I changed from 20 to 16, what would I change? Okay, so looking back at our original equations, which one of these would I change? And there's the 16, so I would switch that to become 20x plus 10y equals 240. All right, so they're just trying to get you to understand how these equations are built. I don't think anything too severe there. All right, if you want to open up both pages now, so you're looking at 10 and 11, the next command they're giving me is to solve the equation for y. We've done this before, so I would subtract an x from both sides. So I would say y equals 18 minus x. All right, and I think you've already done substitution. This was our other equation that we started with, okay? And 18 minus x went in for this y value. Okay, so where did it come from? We substituted it. All right, and the big idea is I can't solve either of these equations if they have an x and a y. So if I'm looking at this, it has an x and a y. I'm looking at this, it has an x and a y. But if I plug 18 minus x in for that y, now I'm only dealing with x's in my equation, okay? And now I can solve it just like I normally have. So I'd first use the distributive property, okay? And I'd like you to pause the video and try and solve it. Pause it, solve it. Okay, so I distributed. The green is, I'm combining like terms. Be careful for that. Don't add 10x and 10x to the same side. I subtracted 180, I divided by 6, and that gave me x equals 10. So you can see if your estimate was close to that. And then for us in a system, we need an x value and a y value. So this says, how can I use the value of x to solve for y? So I can plug it into either equation that I have. All right. So I typically will plug it into the one that I got by itself. So I'm going to plug it into this. Okay. But you could plug it into that. And if I plug it into this, y equals 18 minus x. Now I know x is 10. So that would give me y equals 8. So there's two ways to show your answer for a system. You can say x equals 10, y equals 8, and circle it. Or this should make sense from a graph. We would have a point, but make sure you put them in the right order, x and y. And this says, what do those represent? This was the workers that were outside. This is the workers that were inside in order for us to make $240. So that's the big idea. If I go to, we were just looking at 10, 11, now I'm going to page 12. Okay, this wants me to graph them. I would suggest doing that afterwards to check it. But they want me to substitute for the second part, okay? And all substituting is I get a letter by itself, which right here, I have y by itself, and then I can plug that, in this case it's just an x, but whatever y equals, I can plug into the other equation. So I would get 2x plus, and then I'm plugging in an x for the y, equals 3. This would give me 3x equals 3, and this would give me x equals 1. Then I would take the 1 and plug it into either equation. This is the easier equation to plug it into, and that would give me y equals 1. Okay, so if you did graph this, those two lines should cross right there. Okay, so I'm going to write the substitution steps down for you. You can always check it with graphing. You just have to be careful. If they say solve and you have to use substitution, they want you to do that. So the first thing that I would do is get x or y by itself. I just want to get one of the variables by itself. Okay, the first equation, it would be easier to get x by itself. The second equation, it would be easier to get y by itself. So I'm just going to go with the first one to show you you don't have to get y by itself each time. So now I have x equals 18 minus 3y. All right, and this is the substitution step. Plug in your expression into the other equation. Okay, so I get x by itself. This is the expression that equals x. Now I'm going to take it and plug it into the opposite equation. Again, feel free to pause, rewrite this down, start it back over, especially if you zone out. It's okay, everyone zones out from time to time. Make sure we're zoned in though. So I'm putting 18 minus 3y where the x was. I would still have a plus y equals 17. Okay, and now once I have done that, I solve for the variable. In this case, it's y. It could be x. They don't have to use x and y. But that's our big idea there. So you can pause it. Solve, please. All right, so I distributed, combined like terms, subtracted, divided. Be careful of your signs. I got y equals positive 5. All right, our last step is to plug in our known variable. and solve for the other. So now that we know y, we're going to plug that in and solve for x. So you could put it there, or you could put it there. I think you should put it in the one that you already got x by itself. So I would have 18 minus 3 times 5. And that would give me an x value of 3. So my solution is 3, 5 if I wrote it as a point, or x equals 3, y equals 5. Okay, and that's all substitution is. Sometimes this is the easiest algebraic method, sometimes it is not. This second one says, how could I do it differently? Okay, we got x by itself. We could get y by itself. All right, and I'm not going to have you go through and do that again to see that we got the same answer, because I believe this is a review from last year. So I'd like you to try example 4 by yourself. So pause the video, try example 4. This is on page 14. All right. There's a couple different ways to do it. So if you do it differently than I do, we should still come out with the same answer, but give this a pause and then give it a try. All right, so this one ended up being decimals. Hopefully that doesn't throw you off. It could also be written as a fraction. You could hit the math button and do math frac if you wanted to. All right, and then the question says, what would the system look graphically? Okay, our intersection point would not be on a grid line, so you'd have to figure that out. You could use your calculator to check that. All right, once you have finished the video, raise your hand to get the homework. Okay. Remember, you could always get y by itself for each of them, graph it to check it, all right, but we want you to try and solve it. And then if you finish that, you can also work on the midterm review packet. That is not due next class, but it will be due the following. All right, so I believe that's Wednesday the 19th. All right, and I appreciate you being flexible without me being here for this math conference. And yeah, that's it. Stock money out.